Welcome to another deep dive. Today, we're cutting through the noise to bring you the most impactful announcements from the latest Azure service updates. Our mission is basically to turn this stack of technical release notes into insights you can actually use, helping you understand what these changes really mean for your infrastructure, your operations. We know you're managing complex Azure environments often right at the bleeding edge, so our goal is deliver these weekly updates with the depth you need to stay ahead.
That's right. We're focusing on the updates rolled out between August 4th and August 8th, 2025. This past week saw a really high volume of changes, actually, a significant emphasis on Azure Kubernetes Service, AKS, but also some, crucial developments across networking, storage, and compute, too. We've distilled these into key areas so you can quickly grasp the implications for your technical landscape without, well, sifting through pages and pages of docs.
So whether you're architecting cloud-native apps, optimizing your current Azure setups, or just want to stay on top of all the rapid advancements, you're definitely in the right place. Let's unpack this. Okay, let's kick things off with what's now officially generally available, or GA. These are the features, services that are, fully baked and ready for production. What's leading the charge for GA this week?
Yeah, there's several really crucial launches. They enhance capabilities across the different Azure pillars, giving you immediate value. Started with networking, the private application gateway on Azure Application Gateway v2 has hit GA. And this isn't just like a small update. It fundamentally changes how security-conscious organizations can expose internal applications.
Okay, interesting. So how does this private application gateway build on the existing v2 SKU? And what's the impact of that enhanced control over network exposure for, say, a highly regulated industry?
Great question. The key thing here is its focus on network isolation. So before, while you could lock down your app gateway, this private SKU makes sure the gateway's front-end IP is entirely private. It lives within your virtual network. For a regulated industry, or really any org with tight network security needs, this means you can get wave protection and traffic management for internal apps without exposing any public endpoint for the gateway itself.
Wow, okay.
It's perfect for secure B2B stuff or multi-tenant apps where microsegmentation is key. You don't need complex VPNs or have to sacrifice that network isolation just to expose internal services.
Right, that definitely streamlines the network architecture for internal apps.
Okay, moving over to compute, we've got the GA of the Azure 128 and 192 vCPU sizes for Esv6 and Edsv6 series VMs. These new VM sizes are, well, they're huge. Up to 192 vCPUs, nearly 2 terabytes of RAM. What kind of workloads need that kind of power, and what's the significance of that Intel TME feature? Yeah, these are beasts. They're designed for the most demanding, memory-hungry enterprise apps. Think really large relational databases, massive in-memory analytics platforms, or big in-memory cache workloads that just wouldn't fit on smaller instances. That 192 vCPU size especially is for scenarios needing extreme vertical scaling. And the Intel Total Memory Encryption, Intel TME, that's a critical security piece. It encrypts all the data in main memory, so it protects against physical attacks like cold boot attacks or memory scraping, even while the VM's running. For sensitive data, it adds another layer of confidence, for compliance.
That level of security for data in use is definitely critical for a lot of enterprises. Okay, shifting gears to data movement. Azure Databox Next Gen is now GA in more regions. What's the scope of this expansion? How does it make large-scale data migration easier for global operations?
It's a pretty significant expansion of its global footprint. We're talking Australia, Japan, Singapore, Brazil, Hong Kong, UAE, Switzerland, and Norway. And importantly, both the 120 TB and the big 525 TB capacities are available in these places now. So for orgs with data centers spread out globally, or those hitting issues with network latency or bandwidth for huge transfers, Databox gives you that reliable, secure, physical way to move data, often faster than online. This expansion just means more businesses can tap into this hybrid cloud data transfer solution, especially where cloud adoption is really taking off.
Right, helps with data residency too, I imagine. And for anyone deep into AKS, wow, this week brought a lot of GA goodness. First, the AKS Security Dashboard, it's GA now, gives you that central unified view of your security posture, runtime threats, all inside the Azure portal. What problems does this actually solve for cluster operators who are maybe juggling multiple security tools right now?
Oh, it's a game changer for simplifying security management. Yeah. Before, you might be trying to patch together insights from Defender for Cloud, Azure Monitor, maybe various third-party tools to get the full picture. This dashboard pulls it all together: software vulnerabilities, critical security issues, compliance gaps, active threats, all in one spot. The real insight is how it centralizes that threat visibility. It turns security from, a reactive log-checking chore into a proactive single pane of glass thing. Dramatically cuts down the time to detect and respond across big AKS fleets. It's really about making security operational.
That consolidation sounds like a huge relief for security teams. Okay, staying with AKS, static egress gateway public prefix support is now GA. Can you walk us through the mechanics? Why is predictable egress such a big deal for compliance and, typical enterprise network policies?
Sure. So this feature lets you set up a dedicated gateway node pool just for routing outbound traffic from specific pods you annotate. This traffic then goes out through a static public IP prefix. You can pick a size from 28 down to 31. The big deal is predictability. Many enterprises need outbound traffic to come from known static IPs for firewall rules, for regulations, for audit trails. Without this, dynamic outbound IPs mean constant firewall updates or, worse, security caps. This feature gives you a clean, managed way to make sure your AKS outbound traffic fits those strict corporate network policies. Avoids headaches with external services.
Yeah, predictable egress is definitely huge for many places. And performance-wise, control plane improvements in AKS have gone GA. Specifically, API server resiliency via KP51 streaming and coding for list responses. Okay, that sounds technical. What's the practical impact for a large, busy AKS cluster?
It is a bit technical, but the impact is really foundational for cluster stability and responsiveness. Before this, when a client like Quebec or maybe an operator did a big list call on a cluster with tons of resources, like thousands of pods, the API server had to hold the entire response in memory before sending it. That could cause huge memory spikes, crashes, slow responses under load. KP51 changes that. It streams the response. It drastically cuts memory usage, often by about 10 times during these big list calls, and that translates directly into a more robust, stable API server. Super crucial for CI/CD pipelines, monitoring tools that are always querying cluster state. Keeps your control plane responsive under pressure.
10 times. Wow, that's a significant boost for large-scale ops. Also related to stability, deployment safeguards in AKS are now GA. How does this feature help prevent common misconfigurations and, improve deployment reliability?
This is all about shifting left on best practices, catching issues earlier. Deployment safeguards act like gatekeepers, enforcing Kubernetes best practices right at the deployment stage. Think of it like an automated linter, but for your deployments inside AKS. It helps stop common mistakes, like deploying workloads without proper resource limits or readiness probes, things that often cause instability or outages. By catching these early, it cuts down on bugs and deployment failures, leads to more resilient apps, and, frankly, less firefighting for operators. It's a bit opinionated, but definitely helpful for keeping clusters healthy.
That sounds incredibly valuable for just maintaining cluster hygiene. And for those with the absolute highest security needs, confidential VMs for Ubuntu 24.04 and AKS have hit GA. What does this offer for highly sensitive container workloads? And is there any code change needed to use them?
Yeah, this is a real breakthrough for data confidentiality in the cloud. Confidential VMs, or CVMs, make sure data is encrypted not just at rest and in transit, but also while it's being processed in the VM's memory. So for super sensitive container workloads, financial data, medical records, IP, you can migrate them to ATS node pools backed by these CVMs. You get strong assurance that data stays protected, even from the underlying cloud infrastructure, including Microsoft operators. And crucially, no code changes needed for your existing container images. That makes adoption much simpler. It really enables a lift and shift for sensitive workloads into AKS.
Wow, no code changes. That's huge for regulated industries. Okay, moving beyond AKS for a moment, the network security perimeter is now GA. Can you explain its purpose? How does it bolster security and compliance for PAS resources?
This introduces a new layer of network isolation, kind of a different approach. The network security perimeter lets you define a logical network isolation boundary around your PAS resources. Think Azure storage, SQL database servers, even if they're deployed outside your traditional virtual networks. You can think of it like creating a zero trust bubble around those PAS services. Its main job is to restrict public network access, forcing connections through private endpoints. It gives you microsegmentation for resources that maybe felt a bit exposed before without needing to stick them inside a full VNet. This really bolsters security, shrinks the attack surface, and helps meet strict compliance rules.
More network hardening is always good. And speaking of security, Azure DNS Public Zones DNSSEC, that's DNS Security Extensions, is now available in US Gov and China regions. What's the impact of expanding DNSSEC geographically like this?
This is a critical expansion for a foundational security feature. DNSSEC protects applications from forged or manipulated DNS data stops, things like DNS cache poisoning or farming attacks. By making DNS-SCC GA for public zones in U.S. government and China regions, it adds that extra layer of trust and integrity for DNS resolution, where data integrity and national security are absolutely paramount. It just builds on Microsoft's commitment to secure infrastructure globally, making sure DNS queries for your public zones are authenticated and protected end-to-end.
A crucial step for data integrity, definitely. Okay, finally in the GA category, Azure Storage Actions is now in 22 more regions. What does this expanded global access mean for organizations managing data across lots of different geographies?
This is really about increasing flexibility and automation for storage management. Azure Storage Actions let you automate data lifecycle tasks, like moving data after a certain time or deleting old logs based on rules you set. By expanding to 22 more regions, organizations get wider global access and more options for data residency. So if you're managing huge data lakes or archival data across multiple geographies, this gives you more flexibility to fine-tune storage costs, enforce retention policies, and automate data hygiene much closer to where your data actually lives or gets generated.
All right, that wraps up the major GA news. Now let's shift our focus to what's just entered public preview. These are the features ready for broader testing, giving us a glimpse into future capabilities.
Yeah, this week's public previews show a really strong focus on visibility, network management, and again, more enhancements for AKS. It's definitely a lot to keep an eye on. Suggests where Azure's putting its efforts.
Kicking off with storage previews, we have Azure Storage Discovery. Can you tell us more about the kind of enterprise-wide visibility this offers? How does it help optimize costs and security for those really large storage footprints?
This looks like a fantastic new tool for anyone managing a, well, sprawling Azure storage estate. It goes way beyond basic monitoring to give you deep, enterprise-wide visibility. Before this, getting that holistic view, use capacity, activity patterns, finding stale data across maybe hundreds of thousands of storage accounts, that was a manual, painful process. Storage Discovery aims to bring all those insights right to your fingertips, so you can proactively find underused resources, pinpoint cost savings, enforce security by spotting weird access patterns or misconfigurations. It seems crucial for really managing large storage footprints effectively.
That holistic view sounds incredibly valuable, yeah. Okay, sticking with AKS previews, managed namespaces in AKS, how does this simplify access management, especially for developers or teams needing specific permissions without getting, broad cluster access?
This directly tackles a super common pain point, giving granular access to Kubernetes namespaces without handing out overly broad roles at the cluster or subscription level. With managed namespaces, users can now list only the namespaces they have access to across a subscription, resource group, and cluster. And even better, they can get credentials that let them deploy only to those specific namespaces. This should really streamline onboarding new teams or apps. Platform engineers can set up precise, managed access, cutting down the risk of accidental or malicious mistakes. It's about empowering devs but keeping strong governance.
Simplifying access control is always welcome for platform teams. Another AKS public preview, the Azure Virtual Network Verifier for AKS, VNV. What's this tool designed for? How does it make troubleshooting connectivity issues less?
Well, less painful. Yeah, connectivity issues are notoriously painful in Kubernetes. VNV, the Azure Virtual Network Verifier, aims to seriously reduce that pain. It's available right in the Azure portal. It gives you a comprehensive way to detect and troubleshoot outbound connectivity problems in your AKS cluster. It simulates network flows, checks against your NSG rules, firewalls, routing tables, basically pinpoints why your pods might not be reaching external services. It looks like a much-needed diagnostic tool that could save hours of manual tracing.
Okay, that sounds like a significant improvement in diagnostics. Also for AKS, multiple standard load balancer support is in public preview now. What's the main benefit here, especially for large AKS deployments beyond just pure scalability?
This is a huge scalability and architectural improvement. Before, you were capped at that 300 inbound rule limit per node NIC for your single standard load balancer, SLB. With multiple SLB support, you can blow past that limit. That's critical for clusters hosting tons of services or large-scale ingress, but beyond just the numbers, it allows for traffic isolation. You can assign different SLBs to different agent pools and workloads, so you're effectively creating logical network boundaries within your cluster. You could separate internal app traffic from external ingress or critical services from less sensitive ones, each with its own load balancer and maybe different rules. Offers a level of network segmentation in AKS that was tricky before.
Interesting. That level of isolation could be really useful. Okay, for folks using Azure Monitor workspaces, there's an increase ingestion quota for Azure Managed Prometheus with an ARM API in public preview. Why is this important for high-volume telemetry? And how does having an API for this help?
Well, if you're running large-scale apps and really lean on Prometheus for metrics, you know those ingestion limits can become a bottleneck fast. This new ARM API directly tackles that. Instead of needing support tickets or manual requests, platform teams can now programmatically ask to increase the default ingestion limits for managed Prometheus metrics. It means more agility in scaling your monitoring to match your app's demands. Essential for large-scale monitoring, making sure your telemetry pipeline keeps up with activity bursts or rapid growth without breaking.
Makes sense. Automating that scaling is key. Still on AKS, local DNS for AKS is in public preview. What's the core problem this is trying to solve with DNS resolution, especially in big clusters? How does it improve app responsiveness?
DNS resolution, yeah, it seems simple, but it can be a major bottleneck in large Kubernetes clusters. Leads to app slowdowns, timeouts. Local DNS for AKS puts a DNS proxy directly on each node. So instead of every pod having to reach out to the cluster's central core DNS or maybe an external DNS server for every single lookup, the local proxy handles a lot of those requests right there. This cuts down network hops, reduces load on core DNS, and most importantly, gives you faster, more reliable DNS resolution. The result: lower query latency for your apps. Makes them more responsive, more resilient, especially with lots of inter-service communication or external lookups.
Better DNS is always a good thing. Okay, continuing with AKS, Azure Bastion integration with AKS is also in public preview. What's the benefit here for secure remote access to clusters?
This looks like a great addition for secure remote access. Azure Bastion, gives you that seamless, secure RDP and SSH connection to your VMs right through the Azure portal without exposing public IPs. By integrating this with AKS, it now offers continuous secure access to your private AKS clusters. And even for public clusters, if you use API server authorized IP ranges, Bastion can simplify getting secure remote access to your cluster nodes. It cuts out the need for jump boxes, complex VPNs, or direct public IP exposure. Really boosts the security posture and simplifies life for admins needing to troubleshoot or manage nodes directly.
That's a valuable combo of security and operational simplicity. For application protection, Web Application Firewall, WAF, on Application Gateway for Containers is now in public preview. How does this help AKS admins protect their workloads against malicious attacks?
Right, this brings enterprise-grade application security directly to those containerized environments managed by Application Gateway for Containers, AGC. So AKS admins and devs can now easily shield their workloads from common web vulnerabilities, SQL injection, cross-site scripting, other OAuth, top 10 stuff, using the WAF default rule set integrated with AGC. Instead of needing separate, maybe complex WAF setups, this integrates natively, provides that critical layer of app security right at the ingress point for your containerized microservices.
Security is definitely a major theme this week, yeah. Okay, for storage within AKS, encryption and transit for Azure files, NFS shares in AKS is now in public preview. How does this build on existing security? What does it mean for data moving between the cluster and NFS shares?
So this builds directly on the recent GA of encryption in transit, EIT, for Azure Files NFS shares themselves. It just extends that same security level to your containerized workloads using those shares. It brings TLS 1.2 plus encryption for NFS v4.1 volumes when they're accessed via the Azure Files CSI driver inside AKS. Basically, data moving between your AKS nodes and your Azure Files NFS shares gets encrypted in transit. Strong confidentiality, integrity for your persistent volumes. For sensitive data or compliance needs, it ensures that even if network traffic gets sniffed somehow, the data stays protected. Complements encryption at rest nicely.
Enhanced data security, even in transit. Good stuff. And following up on the Ubuntu CVMs we talked about earlier, confidential VMs for Azure Linux are now in public preview too. What's the significance here, offering this for Azure Linux specifically?
The significance is really broadening the reach of confidential computing. Azure Linux is a key OS for many Azure native services and custom apps. So just like the Ubuntu CVMs, these target highly sensitive container workloads. It means if your apps are built on Azure Linux, you can now shift them to AKS, run them on CVM-backed node pools, keep that strong security and in-memory encryption, all without code changes. It just gives you more flexibility in your base OS choice while still getting that top-tier confidentiality.
Makes sense. More choice is good. Another networking feature in preview, the ability to disable HTTP proxy. What's the goal here? How does it simplify network setup for AKS in those proxy-dependent environments?
This feature aims to streamline network config in those complex enterprise setups that rely heavily on HTTP proxies for outbound traffic.
Before, getting proxies configured just right for AKS could be pretty tricky, making sure the nodes and the pods routed traffic correctly through the corporate proxy. This new capability seems to offer a more direct way to ensure both AKS nodes and pods use the proxy for all the network traffic that needs it. Should simplify setup, reduce potential config errors, make it easier to slot AKS clusters into existing proxy-heavy corporate networks, better reliability, better compliance.
That sounds like a practical win for network engineers. And for absolutely massive network meshes, Azure Virtual Network Manager Mesh now supports 5,000 virtual networks in public preview. Wow! What does this massive scale increase mean for enterprises building really large interconnected network topologies?
Yeah, 5,000 is a huge number. This is a truly monumental leap for large-scale enterprise networking. Azure Virtual Network Manager, remember, lets you create these global mesh topologies, connecting VNets across subscriptions and regions with central management. Before, scaling those meshes to really high numbers of VNets could get challenging. Supporting up to 5,000 VNets in a single mesh topology means organizations can build incredibly vast, secure, highly connected networks for their applications without the nightmare of managing thousands of individual pairings. For huge corporations with complex global deployments or multi-tenant setups, this allows seamless bidirectional connectivity between an immense number of VNets. Fundamentally simplifies network management at serious scale.
The ability to manage that many interconnected VNets in one mesh, yeah, that's a significant architectural boost. Really enables cloud-scale private networking. Okay, and finally, let's peek at what's still in development, or maybe in private preview. These are often early looks at really innovative capabilities, hinting at where Azure might be headed next.
Yeah, these next two updates are particularly interesting. They definitely point towards deeper AI integration right into the operational workflows for AKS. Highlights a clear strategic direction, I think.
Okay, first up, in private preview, an agentic experience for AKS in the Azure CLI. Now, this sounds like a major step. The AKS team is introducing a new agentic AI-powered CLI experience via new command as Agent. What's groundbreaking about this? How does it promise to help developers and operators do complex tasks with AI help?
This is really a standout. It could genuinely redefine the command line experience. It brings agentic reasoning, that's the AI's ability to plan and execute multi-step tasks directly into the Azure CLI. So instead of just running simple single commands, you could tell the CLI a higher level goal, like deploy my app to AKS, or maybe diagnose why this pod isn't starting. And the AI agent would intelligently break that down, figure out the steps, run the necessary commands, maybe even handle errors or ask you clarifying questions. It promises to be a significant leap for dev and operator experience, moving beyond simple commands to intelligent, context-aware task execution. Could really reduce the cognitive load of managing complex Kubernetes stuff.
Wow, that really does suggest a future where the CLI is more like an intelligent assistant, almost anticipating what you need. And complementing that, the AKS Model Context Protocol MCP server is also out in public preview as an open source release. What's its foundational role? How does it help AI agents talk to AKS clusters to simplify management?
Right, this is kind of the underlying plumbing that makes that agentic CLI experience and likely other future AI tools possible. The MCP server is an open source component. It provides a standardized interface, like a common language or bridge, for AI agents to interact with AKS clusters. Without it, every AI agent would need to learn the complexities of talking directly to the Kubernetes API, which is complex and easy to get wrong. With MCP, AI agents can work at a higher level of abstraction, simplifying cluster management by orchestrating actions through the standard protocol. If you connect the dots, it points to a strategic move towards deeper, more sophisticated AI integration for cluster automation, paving the way for potentially autonomous management of Kubernetes environments down the line. It's the foundation for AI-driven ops, really.
What a week for Azure updates. Seriously. From scaling capabilities with new VM sizes, better load balancer support, to just significant advancements in security and management across AKS and broader Azure services, it's clear the pace of innovation is definitely not slowing down.
Indeed. The sheer volume of AKS updates, especially focused on security, performance, and now these emerging AI-powered management tools, it really stands out this week. It signals a clear commitment from Azure, making AKS even more robust, secure, and intelligent for containerized workloads, while still hitting those core infrastructure needs like networking and compute.
Yeah, this deep dive has really aimed to help you understand not just what the updates are, but hopefully their immediate impact and future implications for your own deployments. Staying informed, understanding the why behind these changes, it's just key in such a fast-moving cloud world.
Absolutely. And as we look at these AI-driven tools like that Agentic CLI and the MCP server, it does raise an important question for all us managing these environments, doesn't it? How do we prepare our teams, our processes for this next wave of automation and AI integration? What new skills might be needed? And how might these intelligent assistants fundamentally reshape the operational workflows we're used to today?
That's a great question to ponder. We hope this deep dive into the latest Azure updates has equipped you with some valuable insights. Until next time, keep exploring, keep building, and keep being well informed.